Hi everyone, welcome to the video. Bit of a break from the norm now. If you've been following the channel before, a lot of my videos up to now have been around sort of retro gaming, emulation, a few videos on sort of PC tips and tricks. But this is something I wanted to share. It's something I've done at home on my home network. So yeah, I thought it might be useful for someone. So it's basically the issue I had was moved into our house, well, a couple of years ago now. But the internet connection was complete rubbish. It was slow. It kept dropping. It was unreliable. When I say slow, it was really slow. We live in a village. Having said that, it's not a very small village, but I guess it's small enough. We don't have fibre in the street yet, and like I say, the wiring's obviously quite old and flaky. So we had one visit, and the engineer found 3 faults on the line, which was probably the worst I've ever found. So yeah, so what I did to obviously help with that until they sorted out the cabling was I actually paid for a 4G internet connection. So I got that from obviously I'm in the UK, a company called 3. They provide you with a router. Looks just like a standard home broadband router, but rather than connecting to your phone line, it's got a little a data SIM and connects to the mobile phone network over 4G. And that was kind of like the opposite. It was fast, but because it's a 4G network, sometimes you lost signal with bad weather, sometimes it got congested, so it was faster, but I guess a bit less reliable. And then you had the landline, which was a bit more consistent but slow and would drop out occasionally. So what I wanted was a solution to actually bond the two together and do some load balancing, so that when you connect to the internet, it would kind of, if one failed, it would auto fail over to the other one, and vice versa. And you could load balance, and you could, pin certain things to go out one or the other, depending on what they were. Because one thing I found were, I've got 4 boys, and they do a bit of online gaming, and obviously for online gaming, it's done it. The response time, the ping time is quite important when you're playing multiplayer games. So even though it's quite slow, the fixed line, the DSL line, was actually better for gaming, whereas the latency on the 4G was quite high, so it wasn't much good for gaming. So I could set up rules to say, okay, if it's an Xbox or whatever it is, make sure it goes out of this way, out of the fixed line, which for us was with Vodafone. So what I've come up with was this software you see here called pfSense. Been around for quite a while. It's open source software. It basically tailored to run as a firewall router in one. Now these guys do kind of enterprise business type solutions with physical boxes that you can buy. Even you're a big business, and obviously you pay for support, etc. But they also do a community version, which is pretty much almost the same code, but it's free to use, and you basically download an image and then you run it on a little small PC, or you can buy the little appliances from them as well. I think you can see here, they've got these tiny little boxes which you can run. It's almost like I guess it's almost like a Raspberry Pi type device in a box, and it's got a couple of network interfaces, and that would sit there being a little, they sell these ones as little small office type things, but no reason we could buy that and run that at home. And then, like I say, as they go up, they get bigger, rack mount type servers, with a lot more memory for large business type uses. So, like I say, you can the free version, for the community version, you can download effectively an ISO. You got it for 64-bit. Well, I think the Netgate version is to run on their specific devices, but you can download the 64-bit version. So, like I say, you can run it on any old hardware. I've got it running on a little mini PC, so it runs quite well. So what I wanted to do in the video is just to show basically how to install it from scratch, how to set it up, and then how to set up load balancing, how I've done it, and if you've got some bits and pieces, I guess, on the way. So, like I say, hopefully it'll be useful for someone. Without further ado, let's jump in. So what I've done is I've set up a VMware, Hyper-V, a virtual machine, to actually install it and run it. Just easier to show. So nothing particularly special here. It's a basic little virtual machine. gig of memory, single virtual processor. It's got a single hard drive, the DVD drive, and then in here we just need to mount the pfSense ISO. So obviously that's from the web page I was just on. If you're here and you pick the ISO like that, where you want to pick it, where you want it to come from, and hit download. You'll download the ISO. There's also the option, of course, to put it on memory stick, so you could boot off USB memory stick and install it onto internal hard drive of your little PC, however you want to do it. But either way, you get it onto either bootable ISO that you can use on a virtual machine like I'm doing here, or actually burn it to a disk, or you can basically burn the same image to a bootable USB device. So that's pretty much what I'm going to show here. So in the DVD drive of this virtual machine, I'm just going to mount the ISO. And like I say, we've got a hard drive there, which is definitely massive. The specs for this aren't really huge. I think this is a 16 gig virtual hard drive, like I say, a gig of RAM. And then what I have done is set up 3 network interfaces. You can see them here. Obviously, out of the box, if you don't want to use this as a firewall router at home, because you've got a fairly standard setup, you've got a single broadband connection, you just need 2 interfaces. You need your LANs, your local network connection, and then you need your WANs, or your wide area network, or your basically what's your internet connection. But in my case, because I want to do load balancing, I'm going to have 3 physical ports. So I'm going to have the LAN, so 1 for the local network, and then 2 WANs, so basically two broadband connections. And then what I can do, like I say, is load balance between them. So I've just set up 3 virtual network adapters, and all the rest is pretty much default. So we'll just boot this up, and it should then boot from the virtual DVD drive and that ISO. This is because I played around with it before. I don't want to revert, no. Okay, let's see what it says. I'll revert. Okay, this is because I had it installed, I had it already, and I thought I'd keep it as it is without setting up from scratch, but obviously didn't like that. So let's put the ISO in again. Right, so we're going to boot up now, and we're going to do a run through the install. So this is the virtual machine I'm running, but this is exactly what you'll see if you're installing on your physical device. Just minimize this that way, it's a bit easier to see. I don't think I can. No, can't make it any bigger at the moment. But anyway, so it boots up. You come through this welcome screen, just hit accept here, and then obviously you want to. If it was already installed, you could go through and do some kind of sort of recovery, but we're going to do a fresh install. Pretty much the only options you need to pick here is your keyboard mapping. So like I said, I'm in the UK, so let's find the right keyboard mapping. UK for me. You can see there, continue with UK.kbd. Yep. And then you've got an option here around how you want to partition the hard drive, etc. But I'll just leave it as auto, because I think in most cases you'd have a dedicated hard drive for this, a dedicated machine to run it. So just doing the auto should be fine. Tells you what it's going to do, but we'll just say yep, install. Obviously you have multiple disks, you could set up RAID as well. But like I said, this is a simple machine with a single drive. It's found that virtual disk, so we hit the spacebar to select it. Now hit enter. Gives you last chance before it overwrites. Just arrow across to yes. And now it's going to partition the hard drive for us. Copy some files across. Doesn't take too long. It's quite lightweight installation. I will let it run through in real time. I'm not going to pause the video or anything. I mean, most of the management of this is done just by a web browser. so it's quite easy. There's just initial setup when you first installed it. After here, just to tell it which network interface is which. Basically, you got to tell it which one's your LAN interface and which ones are the WAN ones. So would you like them shared and set any home modifications? Nope. I think we're good with that. Now we're going to reboot. Now, fingers crossed, we shall restart. And then, like I said, just as a quick first-time wizard from the console, just to set up the network interfaces. Because also we can't use a browser to configure it until its network interface is configured and it's got an IP address that we can actually connect to. Okay, so we've got the copyright notice. Just accept that. Oh, it looks like it's probably booted off the ISO again. So let me just fix that. Let's eject that out, and then I'll just reset the machine. Yeah, obviously forgot to take out the ISO image from the virtual drive. Obviously, if you did this on a physical machine, you know that reboot after it finished, that'd be the point you would either eject the disk or pull out the USB stick. So hopefully it's going to restart now. Or maybe not, maybe I broke it. So we can shut down. Yeah, I probably upset it now. Okay, we'll see if this sorts itself out. Obviously, hopefully you won't run into this issue. This is just, I think, because I'm in a virtual machine and I've whipped out the disk, upset it. And turn it off. Right, okay, sorted that out. Obviously upset the machine by removing that disk, so fully powered it off, pat back on again. Now it's booted up from the hard drive, that's all it did. And this, like I say, this is the kind of little initial install that you need to do basically to set up the network interfaces. So like I say, it depends on what you're doing. If you're doing the load balancing, like I've set up, you also need 3 interfaces. So obviously these are virtual interfaces, but for you these will be your physical network interfaces on your device. So you basically need to tell it which one's which. So it's probably worth, I guess, if you find out which one's which, you can do it afterwards, kind of, you know, bit of sort of not hit and miss, but trial and error, and you can set them up. Or if you're able to get into the BIOS of your machine, you can look at the MAC address of each network interface, because obviously these MAC addresses will be unique per interface, and you'll work out which one's which. So I can do this, I say, relatively easy within the virtual machine. So I can see here that I've got these 3, and I know I've got 2 that plug into the default switch. I know they're the ones I want to use as the WAN, and one that goes into the external switch is the one I want to use as the LAN interface, because that's one I'm going to manage it across. And for anyone that's used virtual machines before, plugging it into that external switch means I can get to it from my home network, whereas these two ones will be just sort of internally accessible. So I know that the one ending 08, I want LAN, and the other 2 can be the WAN ones. Doesn't really matter which way around. So 08, so HN0, and there's my LAN interface. So what you say, so do you want to set up VLANs? So that's if you've got a sort of advanced networking set up on your home network where you have virtual LANs. If you've got something like a managed switch, you can designate certain VLANs or networks to each port. But obviously, in most people's basic home network, you've probably just got a standard switch or hub or something to connect your devices together. So we're not going to worry about that at the moment. So we'll say no to set up VLANs. Right, so now it's asked me, okay, enter the WAN interface name. So okay, we know 0 is going to be our LAN. So let's do HN1. That's the first WAN interface. and that's saying enter the LAN interface, so that was going to be HN0. And now you've got optional 1, but in our case that's going to be WAN number 2. So only one left is HN2. So it just confirms here which one's which, so as long as LAN is 0, we're good, and then the two WAN interfaces are 1 and 2. Obviously in your setup, this it's got a temporary name it gives the interface. In this case it's HN. That might differ for you, but like I say, it's just a name or label it gives it. So just you confirm, say yes, proceed. That's just going to write that configuration. And just to finish a bit of setup. Starts all the various services here. Yeah, and that's it booted up. So you can see here it's given the LAN interface 1.1 by default. I need to quickly change that because I know that's going to conflict with my my home network. So option 2 here to set IP addresses. So let's do number 2. Interface you want to configure. I'll do the LAN, so number 2. And the IP address, so I'm just going to give it a, for my home network, my home LAN is 192.168.1, obviously .1 up to 254, that's my home network. So I know I've got, I think like 168 is a randomly free IP address, and then you've got the subnet mask. Generally this will be /24, like I say, so mask does what it says really. So if you got an IP address of 192.168.1, the mask will mask off. So also within each octet here, you've got a maximum of 255 addresses. So we're basically masking off 255 from each one, and then 0 from this last one. So basically the mask says if it's this mask here, if it's /24, it means you can have a usable address in this range is from 1.0 up to 1.254. That's your 255 addresses, and obviously, like you say, there's other ways of making it bigger, but generally most home networks are going to be this one /24. Enter the subnet bit count, which is the 24 I was talking about. You don't have to worry too much about this, as like I say, 24 is the default. If it's anything different then you probably know. So then it's asking me to enter a WAN. So for the WAN, enter the LAN upstream gateway IP address. But this is a LAN, so we don't need to do that. IP6, I'm not using. I don't want to do DHCP because that could really break my home network. Revert to HTTP for the configurator, say yes. And now that's just going to reapply that. And now it tells me that I can now manage this in a web browser from that IP address. So now we see we've got the LAN interface of 1.168. The first WAN interface, it's just says it's using DHCP to get an automatic address. But that's fine for now. So what we can do, we can leave that now. We can actually go to web browser, go to the IP address that we set up. Not that. So I put in 168, didn't I? So now we get the welcome screen. There's a default password of admin and pfSense, all lowercase. You'll get a welcome, you'll get a warning until you change the admin password from default. We get a quick welcome. It says about a support. I'm giving it a name, which this I'll call pfSense for now. Actually, I might just call it demo because the pfSense already exists on my home network, so I don't want to break anything. Getting that domain name, I'm not going to worry about at the moment. For DNS, we can have this. Also, I do have DNS running on my home network, but just for this, we just use the standard Google public DNS servers. And just say, yep, okay. And it's going to ask it to for a time zone. So configuring that WAN interface, we can do statics. We can control what IP address we give to the WAN interface. So actually this you can give as default, but so what I'm going to do is give this an IP of 192.168.100. Got 254. Subnet mask again of 24. And then the upstream gateway is going to be .1. So I've done a quick diagram to help explain this. It's a bit basic, a bit noddy in Paint, but so like I say, this is kind of roughly what I've got at home. So like I say, this is a Vodafone standard ADSL phone line broadband router that's here, and this is the 4G one over here. Obviously both fairly standard home routers, one connects to the phone line, one connects to 4G, and then down here I've got the NetGate device. Mine's just a standard little mini PC. It's not actually a NetGate device, but you know, you get the idea. Especially you need a PC, old little PC with at least 2 ports in to use, and then I've actually got a mesh network for Wi-Fi, which is separate. So because when I run these like this, these routers here, normally your home router would do everything. It'll be your DHCP server, it'll be your wireless access point, it'll be your router, it'll connect to the internet, it'll be act as a firewall as well, very basic firewall for you. What we're doing, most of that we're shifting to here now. So this is going to be our router and firewall. So the other thing I do on these to prepare to get this to work is basically obviously change their IP address. So like I say, so the first WAN interface will be a .100 address, and the second one is a .200 address. So that's why I'm typing in. So we'll work on this one here first. That's why we're calling it 100.254. So the .254 is the IP address of this port here, and then the .1 is the IP address of the router. So hopefully that makes sense. And yes, then obviously for this one 200. So like I was saying, so change IP address to the router, but then I do things like turn off the Wi-Fi on here and turn off the Wi-Fi on here, and then so my only Wi-Fi is through the mesh network. So like I say, these things literally just act as routers now. They don't do DHCP, they don't do, again, DHCP is turned off, DHCP is running on here as well, and obviously this does all the firewalling as well. So the firewall on here, I think I'll pretty much end up turning off. You could leave it on, but just in case you get some issues, but we're basically letting this device do all the firewalling for us, because the way we set it up is all internet traffic from your home network will now come via this as the default gateway, and then it will send it out either here or here, depending on how you've configured this. So we're configuring this first interface here now, which is why we give it this IP address. There's a whole bunch of other stuff you can set. So this is all kind of like if you were connecting directly to an endpoint where we're not using the router to do it all for us. So we just need the IP address information. We can just hit next on this. I'm not going to change the LAN interface, that's fine. Password, it's going to moan, so let's just do 1, 2, 3, 4. Hopefully, let's do that. No thanks, I'm not going to save that. And now we're going to reload. I'm not going to see that in here. No, that's too quick. Right, so we're done now. So the basic interface, like I say, you do a little bit from the console, and then you do stuff from in here. Just set up the first WAN interface. So again, you get this kind of welcome message, the terms and conditions. Just accept that, and there's an option to do a survey. So this is the main dashboard. What I tend to do is get rid of that one and then add in one for gateways. So see, at the moment we've only got two interfaces set up. So we've got a LAN one, which is the one we're on now, 1.168, and then we've got our first WAN, our first broadband connection on 100.254. So the next thing we need to do is just configure this opt. So what I'll do is this WAN I'll call WAN 1. IPv6 I'm going to turn off, not using that at the moment. So it's enabled, turned off that. I've just changed it to VLAN, sorry, we called it WAN 1 so we know what's what. That's the information we put out a minute ago about its IP address, and then the upstream, so the IP address of the Vodafone router. .1, and we'll just save that. And then for most things in here, once you save it, you have to click apply for it just to apply any changes that you've made. We're back to interfaces now, and this optional one interface, so we'll enable it, and then we're going to call it WAN 2. IP configuration is static, no IP6, and for this one we're going to do 192.168.200.254, which is again /24, and upstream gateway, we're going to add a gateway, and we're going to call this WAN gateway 2. We've got 1, and we'll just paste that in as well. So again, this interface is 200.254, and then the IP address of our 4G router is 200.1. Normally you block these because this is blocks any traffic from kind of private networks going out onto the internet. So your 192.168, anything like that, stops it going out the WAN interface. It's just best practice. Again, we'll hit save and hit apply to apply the changes. I have found running it in a virtual machine like this, it does sometimes not quite as quick and snappy as it should be. But when you're running it on a physical machine, you won't get this. So all I'll do is go back to the main screen so we can see what's going on. I mean, it may be that because I've put the details in now, it's trying to get to these gateways, and obviously they're down, so it might be causing it some issues. That's working. So anyway, now if we go to system and we go to routing, so we've got two gateways. We've got the first WAN gateway and we've got WAN gateway 2. I don't think it'll let me rename that for some reason. Got WAN gateway 1. Yeah, you can't change the name of the gate. So if I wanted to change that, I'd have to delete and recreate it, but that's fine for now. So you get the idea basically. So we've got under gateways, we've got two gateways set up. So the gateway 100.1 and 200.1. That is 100.1 and 200.1. So it's the IPs of our two routers we've got, our two broadband connections. And then down here you've got default gateway. So at the moment it will pick and choose which gateway to go out, and it's a bit random. Or you can pin it and say, so at the moment you see 1 is a default gateway. But what we want to do is load balance these and make them fault tolerant, so if one goes down it will send traffic to the other one and vice versa. So we go to gateway groups, And what we do is we create a new group and call it load LB gateway. I think you're not allowed to use special characters or spaces, so LB gateway. So we've got two gateways here. What you can do is set tiering. So if we set them both tier 1, they're basically equally balanced, and it'll balance between the two. Depending on what your setup is, you know, if your first one is really quick, your second one's quite slow, you could have your first one as your primary and set this as tier 2. So if you do that, all your traffic's going to go out number 1. If number 1 goes down, it will fail over and everything ends up by number 2. But if you've got evenly matched, or roughly evenly matched, like I've got, set them both to tier 1, and they're both equal then. And then you've got what triggers a failover. So member down means if one gateway goes down completely. The other one is if you have packet loss. So if the gateway is up but you're losing a certain percentage of packets, i.e. there's a problem on the line, then it will fail over. Again, if the latency goes really high, so obviously technically the link is up but it's running really slow, you can then make it fail over. Or you can have a combination, whether it's packet loss or latency, then fail over. Description I can leave blank. Apply changes. Now we go back to gateways. Now under the default gateway for IB4, we can now pick load balance gateway. Hit save on there. Apply changes. So that now means that anything on my network is going to go hit here, and its default gateway will be the load balance gateway, and that will take care of the load balancing, and it will send traffic out of either one. So that's kind of the basics really. That's the interface set up. That's pfSense running, and with the balancing running. Like I said, this is a little bit slow on the virtual machine. So what I will do is just show you my actual copy of pfSense. The only difference is I've changed the theme to black. I think in one of the settings here, might be general setup. Somewhere there's a theme, so pfSense dark is what I've got it set to. But anyway, so you'll see here I've now got the two gateways set up, and for monitoring, it basically pings an IP address out on the internet and gives you sort of the response time, and then any packet loss, and if they're online or not. If anything happens, if the packet loss goes up or latency goes up, this will go yellow. If it goes up beyond the threshold, it will go red, and then stuff will start being pushed out the other interface. So you can see here traffic going in and out of my network into my local LAN, and then the traffic's going in and out of the two WAN interfaces. So you can see how it's balancing. It's not very busy at the moment. Kids are in bed, so there's not much going on. But yeah, you can see how it's load balancing between the two. So other various information here about the machine, sort of the performance and stuff. You can see this machine I've got running has got 2 gig of RAM, but it's barely using any. CPU is always quite low. Yeah, some other information you can add here to the screen. You can see here it's pretty much the same, but I've done 10 and 20 rather than 100 and 200. I went with 10 and 20. As long as it's different, as long as it's outside of that range, that's fine. You just pick 2 unique IP subnets to use, and you're good to go. Then if you want to get sort of a bit more advanced, within the firewall you can set up rules in here. So I've got a few rules that basically send certain things a certain way. So I can say, okay, if it's when I've got Plex running on my home network as well, it's on this IP address, so I can say anything coming from this IP address, push it out gateway number 2. Because like I say, generally the 4G is faster, so if I've got friends sharing and streaming, I want them to go out the 4G, so that forces any traffic that way. Like I see here, we've got the Xboxes and some switches. And like I say, the gaming is better out of the Vodafone, out the fixed link, so that goes out of WAN gateway 1. So I've got some rules here that say, basically says, match that IP address, any port, any destination, doesn't matter, as long as if anything comes from that IP address, basically go via that gateway, and that's pretty much it. There's a couple here that have been changed to gateway 2. That's purely because they were downloading some updates and they were going a bit slow. Everything was trying to go through the Vodafone link, and it's a bit slow, so I changed these temporarily to go via the 4G, but I can change this back now. So you just hit edit and you can see, so the action is pass, LAN interface, look for IP4, anything from that IP address you match, and then under advanced settings down here, so there's a whole ton of stuff you can do. Gateway, go out via the 4G, but I want to set it back to that now. So like I say, for gaming it's better to go out of that one because the latency is generally better. And then this one as well, I'll set back to the Vodafone connection and just apply that. So they're all set to back to one gateway 1 now, which is all good. So they're all going to go out the right way. Just one thing to note: if you do make some changes in here and you set up some rules and you find it's not working, it's generally if your device, say in this case an Xbox, has already made a connection, then that connection state is going to be kept by the firewall, so it won't take effect until either that Xbox is powered off for a little while and power back on again and re-establish its connections, or you restart the firewall itself, which is probably a bit drastic, which will affect everything on the home network. The other way you can do it is so that Xbox, so for this one for example, is 1.131. So if I go to diags and go to states, this shows all the connections established through the firewall, from stuff on my home network or stuff remotely coming in. It shows all the stuff that's connected. So if I look for that IP address 192.168, or not, I'll just type it manually. .131. So this shows all the connections that device has made, and I can click kill states, and then what that will do is it will reset those connections and basically force the Xbox to then re-establish, and when it re-establishes it will then read the new firewall rule, which is telling it to go out a certain gateway. So that's just something to bear in mind. And I have got the default rule down the bottom here. I can't remember whether I created this or this is one that auto creates for you when you set up the balancing. It's basically saying anything that's coming out of the LAN by default go to the load balancer, which has got these two in it. So basically the rules are read from the top down. So like I say, it'll go down and it'll read these and say, okay, if it's this, go out this gateway, if it's that, go out the other gateway, etc. And then anything that doesn't match those rules basically hits the default rules here, one for IP4, one for IP6, and tells it to go to which gateway to go to. So I think that's kind of it. I don't think there's much else. I mean, I've set up some other rules in here because I work from home a lot, so I've got things like WebEx calls, MS Teams calls are given priority. So you can set things like there's a high queue there. So that basically means that if there's high contention, there's the kids are on their tablets or their switches or whatever, and the bandwidth is getting a bit limited. Basically, my stuff here, the WebEx call or the Teams call will take precedent, and it will go into a queue that's higher. So if like I say, if it's getting really busy and the firewall's got to basically drop some traffic to let stuff through, it will drop the other stuff and it won't drop my Teams calls, which is good. So yeah, there's a whole bunch of stuff you can do with this. And like I say, having the pfSense firewall and router, obviously you can do the routing, but also the firewall side of it gives more security for your home network. You can also set up a VPN gateway on here. So if you're out away from the home, you can use your phone or whatever to VPN back into your home network, and this will be the VPN server. Just do stuff like that. There's a whole bunch of other stuff to do. So yeah, VPN there. Under services, also there's things like DHCP and DNS. So like I say, I've turned off DHCP, which is, for those who don't know, that's obviously the dynamic host configuration protocol. Basically, when you turn a device on, connect your home broadband, your home Wi-Fi, everything needs its own IP address, and normally the router has a pool of addresses and hands out next available address to your device. So I do that on here as well, and DNS is done on here as well. So yeah, it's pretty much the like say the core of the network. Like, so you go out to that picture, pretty much everything runs through here. Like I say, these routers literally just act as dumb routers. Everything, all the clever stuff's done here. Like I say, Wi-Fi is turned off here as well, so all Wi-Fi is with my mesh devices, which work really well. I've actually got 4 of them dotted around the house, 2 downstairs, 1 upstairs, and 1 outside. So yeah, good coverage for that, and that's really well. And that's pretty much it. The only other thing to say about this device, or this diagram, sorry, is some people might think, you run everything through that hub. These are different networks. You might want to separate off, or you could separate them off physically. Mine's connected like this just because of the layout of my house and where the cables run. I'll go into detail, but basically I had to do it like this. Whereas what you could do if you want to, just for demos, you could, rather than running everything into here, you could this cable here. Oh, I don't know where is it. If we I think I'm trying to raise the bottom in the wrong layer. Layered picture. But what I was going to try and do obviously not working for some reason. Anyway, what I was going to try and say, I was going to erase this one out, and so what you could do is just run a cable directly from that router into the whatever your WAN 1 interface was on here, and again this cable here, imagine that one's not there, and you could connect this directly into the interface for WAN 2. You still want obviously the interface for your LAN to go to your home network, whatever that it might be. But yeah, so like I said, I've got everything going in here. You could probably better practice to physically connect these directly to the WAN 1 and the WAN 2 interface here. But like I said, I had to do this because of the way my house is laid out, unfortunately. The other thing you can do is obviously this is basically a dumb switch that I've got here. What you can do is get a managed switch or an advanced switch, which lets you do the VLANs, which is what we looked at the beginning, that first option to set up. So you could do something like making your home network VLAN 1 and make all the ports default to VLAN 1, so anything you plug in is on your home network. And then what you could do is set up a VLAN 100 and a VLAN 200 and say, okay, this port that this plugs into is VLAN 100, and then the interface here for WAN 1, the 100 addresses, whatever that port plugs into is VLAN 100 as well. That way, these two devices can, the only things that can talk to each other, they'll both be on VLAN 100. This port here and this port here for WAN 2 would be on VLAN 200, and they'll be the only things that can talk to each other. And everything else on your home network could be in VLAN 1, and that will give that level of separation as well. You could do it that way. But yeah, I just wanted to show, give the diagram to you an overview. Hopefully, it makes sense of what to do with the IP addresses here. So yeah, hopefully I'm starting to ramble a bit now, but hopefully that's helpful for people. Like I say, yeah, it's good product this. Like I say, I've got running on a little mini PC that's got 3 network interfaces in it, and yeah, runs really well. It's always, it's not very busy. You can see the CPU is quite low. Not much going on at all. And like I say, I think I've 16 gig disk in this one, and it's using the 5%. So I mean, my home network is fairly busy. I've got, like I say, you've got 4 kids. They've got switches. There's Xboxes. There's tablets. There's phones. There's my work machines. We've got Google Home devices and Google smart speakers in most rooms, and obviously smart sockets and some smart light bulbs as well. So all that's connecting to the Wi-Fi and to the home network. So there's probably 30-40 devices connecting, and like I say, this thing handles it really well. And yeah. So like I say, it's done exactly what I wanted to do. I now have basically 2 broadband connections that I can load balance, or I can manually control what goes down which one. So yeah, it works really well. Hopefully this was useful to someone. Hopefully, I just I think I just did the share. I was quite happy with how it turned out. Obviously, it's all free. I already had the PC already, so that was good. Like I say, the software's free. It's just the time to set it up. But like I say here, it doesn't take too long. It's pretty intuitive. So yeah. Obviously, if you liked the video, please like it. If you didn't, don't. And please subscribe if you can. Obviously, it's completely free to you, but it means that any new videos that I post, you'll get notifications of those. So please do that. Any questions or comments or things you think that I can improve on the video, or any other video, I guess. But I guess in this video that you think, or maybe it's not right, maybe I've got something wrong. I'm not claiming to be a networking expert. I work in IT, but obviously, I'm other areas other than networking. But I've got a basic grip of networking. So hopefully everything I've said makes sense. But yeah, if it doesn't, please let me know. And like I say, yeah, hope you enjoyed the video, and I'll be back with another one very soon. Cheers.